Hello friends, I'm Professor John Gallaugher, and I teach a class called Physical Computing, Art, Robotics, and Tech for Good. For the Tech for Good portion, our students have been working on assistive technology projects with our partner, the Boston College Campus School, an on-campus learning program for students with physical and developmental challenges aged 3 through 21. Now, each student created an Instructables page so anyone can build similar projects to help people in their own communities. Megan McGowan, Campus School's Assistive Technology Specialist, generously worked with our students throughout the semester, identifying areas where Boston College students could use their management, design, and engineering skills to build real projects that improve the lives of her students. Here's a look at what they built. Abby made an interactive Very Hungry Caterpillar, making a favorite children's book come alive. She thoughtfully added a jack so that students could use a light touch Assistive Tech button or other gear with a standard aux plug to work with her custom crocheted build. But even cooler, she stitched an RFID reader into the caterpillar's head so that an enabled student or instructor could feed the caterpillar and get both audio and light up feedback on the chosen food. A very creative idea that links reading with play. Tommy K created a remote-controlled light touch button so that a student in a wheelchair could easily trigger the Keurig coffee machine to prepare a brew. This allows campus school students to more fully participate in manning the school's coffee shop. Tommy built the custom rig with a Velcro attachment so that the tech could easily be moved to work with other push-button products as well. Siga's project helps the campus school kids get musical. It's a xylophone that can be played by someone with severe mobility challenges. The fabric-coated blocks detect a touch that's relayed to a mechanism that fires a solenoid that strikes the appropriate note on the xylophone. The blocks can be mounted on a wheelchair tray, and if someone keeps a hand on the block, the note will continuously play. Everyone at the showcase loved trying out Siga's work, and her earlier glowy squeeze ball for make art was also a crowd favorite. Drew and Sawyer built a way for students with mobility restrictions to still participate in feeding their beloved classroom fish. Their custom designed and built button has an accessibility jack, so it's easy to be placed in a wheelchair tray, and an LED light-up fish provides more confirmation that the fishy snack was delivered. Mitch built an accessible Pong game for students with mobility challenges. This game is slower than standard Pong, with larger paddles and numbers showing point values, and control simply requires a student to block the top of a distance sensor to move the paddle in one direction, unblock the sensor, and the paddle can move in another direction. Now, thanks to Mitch's creativity, kids who struggle with fine motor skills can still get in on video game play. Javier built a magic mirror for students with cortical visual impairment. When a child presses their assigned button, their name scrolls across the LED matrix in large type and with their favorite color, followed by a personal greeting, a randomly selected affirmation, and a short favorite song. Javi built a fun way for students to start their day. Tommy A built a visual timer for a deaf student. The numbers are large and the display is colorful, and the countdown timer calibrates with a visual display that shows an animation being built up to fill the entire screen as the timer gets close to its limit. The design is sturdy and the options versatile, a solid design based on a student's specific needs. Nate and Adam built a fun way for campus school students to work on their motor skills through gameplay. A light animates through an LED tower. If a student presses the button when the light is on top of the randomly positioned target, they're greeted with a randomly selected victory light show. A potentiometer can adjust the speed of the light movement. The button has a standard aux connection so that other accessible switches can be used, and the design is portable and can be positioned on its side if that's more appropriate for a given student. Brendan built an Assistive Tech foosball. The game's smaller and slower to accommodate students with motor control issues, and the game is played with a larger ball. Brendan demonstrated with capacitive touch that's even easier to control than light touch buttons, but 2 aux jacks expand the possibility for input and control. Justin made the beloved children's classic They All Saw a Cat come to life. As the pages are turned and touch-reactive strips are touched, a Bluetooth signal is sent from a Circuit Playground Bluefruit attached to the book to another that's inside the cat, and the cat will speak the story. A fun way to engage students and promote attention during story time. Min-Q and Alfonso made an accessible Plinko game. Helpers place balls at the top of the Plinko mechanism. The ball is directed by an arrow mechanism controlled by a servo that continually swings left and right, and students use light touch buttons extended to wheelchairs to release the ball when the arrow is pointing in the direction they want so they can try for a best score. A distance sensor records where the ball lands, a light strip shows point values, and when the strip is full, the strip lights up in a rainbow party. And Steph and Paco help fulfill campus school students' need for speed by building a race car. Scanning a QR code brings up a remote-controlled website, and button taps can increase acceleration or stop the motors. I'm proud of the work that our students have done. These projects were a great way for students to combine engineering and technical skills, management planning, and apply the university credo of being men and women for others. All projects were built using CircuitPython. If you'd like to learn how to build projects like these, I've created over 100 video lessons on electronics and programming that educators and independent learners are welcome to use. All of my course challenges and solution slides are in an open course Google Drive on my website. It's all free online. Find them at these URLs. And if you find it useful, let me know. And also, feel free to leave an encouraging word to my students in the comments. Thanks for watching.